So I'll be very brief, but he's, for those of you who don't know, CEO and co-founder of Pragma. He's successfully led Pragma to become a multinational solution provider in the space of physical asset management. I recognise the multinational because I've had the pain of bidding against them in some jobs overseas, so we know all about that. He's one of the founding members of SAMA and inspires and leads many organisations through their boards and initiatives. I would also, as the chair of TC251, just like to flag that I know we've had contributions both in terms of people, brands, and sponsorship for our meetings of the ISO committee that led us to ISO 55000. A lot of that's come from Pragma as well, so like I said, personal thank you. It's all yours, sir.
Thanks. Morning, ladies and gentlemen. I see there's a few missing, but I'm sure they will come and join us a little bit later. Yeah, we've seen a lot of things during the first day, and going back to Warwick and talk about the things, or think about the things he was talking about. The one thing he said is, what is the world that our story is busy telling? What is the story in the world that I'm trying to build? Now, it's fairly simple. We need to make asset management more effective. So one of the stories that I want to tell is that we need to automate our business processes using technology. We must also start using technology to sharpen our decision making. And we must also make sure that we rig technology and use technology to ensure uptime and safety of our assets. Because this is why we're here. This is why we're asset managers. And I've looked at my presentations over the last 3 years. I've done the keynote there, and there's a consistent story in terms of trying to predict what the future is, talking about IoT, talking about Industry 4. But Industry 4 and IoT is now with us. We now need to do something about it. So today I'm going to try to be a little bit more practical in terms of how do we actually connect and use this ecosystem that we can make sure that we empower ourselves with better decision making, and that we make our lives easier, and that we get to our goals faster and more accurate. I'm going to start off with another video, and there's a few videos that not from ourselves, from partners. So if you see other logos and so on, it's with compliments from ourselves that we also like to introduce them. And let's watch this video and what it has to say with regard to IoT and the future of connectivity.
There is a storm raging, a perfect digital storm, the impact of which will be felt for generations to come. Within this storm, mobile, social, cloud, analytics, and connected devices, or things, are rapidly transforming businesses and consumers around the world. Think about your business. Where is your business in all of this? The decisions you make today will determine your business's fate in future. Can you see your path into the new business environment? We can, with the Internet of Things. The demand for better quality, cheaper and faster is creating a world of doing more with less. The tool sets to achieve this already exist. Big data, cloud, analytics, and unprecedented connectivity. Millions of devices connecting millions of things. Can you imagine if everything in your business was connected, working towards that uber-efficient future? Staff, processes, systems, products, logistics, assets, all talking to each other. Imagine what that would mean for your business. Imagine what that would mean for you. Do they speak to each other? Are they fully integrated in a single view so you can manage all the levers that make your business tick? Probably not. A new era in business has arrived. Working in silos is no longer good enough, regardless of the legacy systems you may already have. It is now possible to create one integrated view of all your current segregated systems. The solution is IoT.next. The IoT.next platform takes all your things, all your different systems, all your different senses, everything relevant to your business, and places all of these in a single view that you can manage. The IoT.next platform makes the Internet of Things a reality. Complexity simplified. The future is real. Let us take you there.
Okay, to take us further, I thought it's a better idea to get some experts. You need partners in this game, and to make sure that you address all the experts, like all the expert areas within within this arena. So I've invited four young gentlemen, and I want to introduce them and ask them to please come to the podium. Dirk Jansen van Rensburg, Darren White, Stefan Swanepoel, and Maurits Hastrom. So please, if you can join us on the stage. And I'm going to stop doing the talking and ask a few questions so that we can get more expert advice and more deep dive into this. Everybody asks me, so what have you studied? I said, well, I'm an industrial engineer, and industrial engineering is just, don't get technical, just point. So at this moment, I'm not going to get technical, I'm just going to point. Okay. To build a picture of what we're going to talk about, I want to connect a few dots. And those dots start with an asset. Obviously, this is about asset management, so the center and the nerve of this whole picture must be the asset. And then from that asset, we're going to talk about the connectivity, giving the asset a voice. From giving that asset a voice, we're going to talk about big data, we're going to talk about artificial intelligence, we're going to talk about machine learning, because all these things will play a role in this whole picture. Then we're going to go up and say, well, we also need to communicate with humans. So how do we out of this also communicate with you, with the financial manager, with the asset manager, with the artisan, with the foreman, the people that's responsible for managing assets on a daily basis. And then the last one, augmented reality. I don't really know what it means, but let's think about augmented reality, and we're also going to talk about augmented reality. Okay, digital twin. So Dirk, this whole story of digital twin, if I think about my Navy days, we had drawings, we had CAD, lately there's CMMS systems, we've got asset registers, and still, that's my world, and still these youngsters tell me, no, Adrian, there's a digital twin, and this digital twin is going to play a so important part in this whole setup of IoT and this connected system. So Dirk, enlighten us a little bit on what is a digital twin?
Well, good morning, Adrian, and everyone here. Thank you very much for inviting me onto this panel. And I must say, my impression or ideas of a digital twin actually changed in the last 24 hours. So I don't know if you were present at Ricky Swanepoel or Dr. Ricky Swanepoel's presentation yesterday.
I wasn't there.
Is she here today?
Ricky Swanepoel, is she here from Eskom, I think? Not.
Very, very impressive presentation, and that shaped a bit of my thinking around digital twin as well, in the way that Eskom is taking their 3D CAD models and actually using that as the fundamental base of their digital twins, and for the whole Kusile power plant, actually building everything on top of that condition monitoring. So if you can get your hands on that material afterwards, perhaps do so. It was very, very impressive.
I'll use that.
Yeah, but coming back to your question, what is a digital twin? So fundamentally, the digital twin is a dynamic digital model that represents as a representation of a physical asset or a thing. And what that means is a digital twin is this mechanism that will in future connect smart assets with smart people. So from that point of view, it will become incredibly important in our lives. So what the digital twin will try to accomplish is try to represent, be a real representation of what is happening to the physical asset out there. And with that, one will be able to get much better responses from this digital twin and be able to affect change much better, much quicker, in a much more dynamic way. So there is, of course, an expectation that comes with that. There's an expectation that this smart asset would be connected in real time with the digital twin. There needs to be some sort of information flow, dynamic information flow into this digital twin. There's an expectation that this digital twin will have some sort of ability to store information. And also the information that resides there should be supplemented with external data, contextual data like temperature, ambient temperature, or perhaps data from the OEM or from people actually entering it, static data as well. And all of that, putting all of that together, you would be in a much better position then to drive optimization, to drive to lower capital expense.
So thanks for that, Dirk. And who today still suffer of looking at their asset register in the CMMS or in the enterprise asset management and then go like, oh, you know, this thing's not accurate. We need to do a new data project to update the data in the asset register. So there's a few hands, more hands, everybody updated asset registers. I mean, it's a continuous struggle. So just think about the digital twin. You know, this thing must be 100% accurate, 100% representative of what's in the field. But obviously technology is going to help us with that. But then, you know, Dirk, if we, you know, look at digital twin, starting off with the asset register, obviously there's a little bit of a maturity growth and a path that one can follow. And I've seen a few things that you've mentioned, but please help us out. You know, how can we actually start building and start using our existing data and build on that to get to a more mature asset register or the real digital twin?
I think it's a very relevant question, Adrian. So we've all seen these videos, right, in the last 2 or 3 years, and Simon, our beloved president here as well, introduced a lot of these very sophisticated videos in his opening speech about, you know, this very interconnected world and a very mature view of the digital twin. But the reality is it all starts in a very basic way, in a twin that we refer to as a status twin. And that is just the ability to record very static, well, dynamic, but single measures about a twin. Just measuring, is a twin, is the asset actually active, is it producing, where's its position, those basic things. And it's in a fixed schema. And then there's a logical growth path along the maturity of the digital twin. And with it obviously comes a lot more investment, but a lot more value to extract as well. And the next logical step is something we call the operational twin. That's really the point where you add a lot of flexibility to your models, flexible data models. You're able to scale horizontally across many assets and vertically, so you can add in more measuring points and other data to this data scheme. And the team and myself, we put together a little model, this little Lego model. Some of you are welcome to go and visit us afterwards, and we can take you through that. That's a typical example of operational twin. The next thing you typically like to do is to start identifying certain patterns or certain behavior, which is referred to as events, and link that to certain data sets. And that would be referred to as supervised data. Once you're able to do that, you're in a position to apply techniques like machine learning, and my colleague Stefan is in a much better position to actually elaborate on what machine learning is all about.
We'll tap into him.
And once you're in that position, you really position yourself to actually start doing simulations of the real environment, and also doing some sort of predictions, which becomes very important. And then the next step, and I think that is really where a lot of the audience in this group is really aiming for, is a point where you can actually use this and marry the digital twin with financial models, marry it with people, and marry it with processes, and really start gaining that kind of benefits and value. And obviously the most mature, and again, that's what we're seeing in all these videos, what's referred to as autonomous twin. At that point, the digital twin will actually be able to take control of the asset and actually make all the decisions and actually basically run the asset. And at that point, there's very little human intervention.
So this whole dream of looking at the digital twin and having that in front of my screen, I can now start looking at new maintenance practices, try those new maintenance practices on this digital twin, see how it behaves, and then I can start implementing. Is that more or less the things that we're going to do? For sure.
Yeah, look, and I think the thing that we often underestimate, there's a lot of these building blocks that's already in place today in many organizations. Take, for example, the status twin. That's very much in line with the traditional SCADA system, where we're already measuring the basic operation of the equipment. So we've got a lot of this in place already, and it's really just a process of understanding the natural growth path and understanding what model to apply to which asset from a strategic point of view.
And I've also asked Dirk, so is there such an example in our daily lives of where digital twin is actually active and where we start building on this? And I think he came up with a very live example. So just quickly take us through that example, Dirk.
The best example that I think of, guys, really understanding the digital twin and applying it usefully is not from our own industry, it's from the financial services or life insurances industry. It's discovery vitality. And if I'm not mistaken, we've got 4 assets sitting here on stage today, and all 4 of them has got a sensor on them.
I've just done 1,000 steps. Heartbeat is okay.
So I can measure my heartbeat now, and 131, gentlemen, where are you standing? What's the nervous factor around the table? 79, I've got a professional here on the stage. Okay, so I'm less nervous than anyone on the stage. Okay, but so currently we hooked up to this thing, and somewhere in the cloud, Discovery knows what our heart rates are, and how many steps we've done today, and all of that. So somehow they've been able to equip all of their assets, or most of them, with sensors, and they're getting this performance data. And they've built this digital twin ecosystem, and they've been able to get other organizations, large organizations like retailers, the healthcare industry, even the financial industry, to actually contribute to this digital twin ecosystem. And the 2 things I think that's most impressive about Discovery is firstly the scale at which they were able to do this. The guys that got on board and the number of devices they got out there, people that contribute. And the second thing is they really use this to effect change to the behavior of the asset. I look at myself, every now and then on the Thursday evening, I actually go out for a jog to get my points so they've actually influenced the way I as an asset behave. And I think there's a lot that we can take about that, at the scale at which these guys are doing it, and the way they understand it, and the way they've integrated this digital twin concept with their financial models. So the benefit for them is fairly clear. If you get the assets, the human beings on their programs to actually make intelligent, healthy life decisions, the risk profile of the people goes down, less catastrophic failures, so to say, every now and then, and the cost of maintaining these assets, the healthcare expense that they obviously need to fund, also goes down. So the financial benefit behind this actually makes a lot of sense, and they're able to do that quite successfully.
And I think if you study this example of discovery and then draw it back to your plant, you can easily see how one can also start building such an ecosystem. Okay, but let's go on. The next thing that we need to do is we need to give each and every of these assets a voice. And the way to give them a voice is to hook them up with some sensors and so on. So I'm going to show a video of such an ecosystem where we now take an asset and we hook it up, and we now start using, or not using the information yet, but we collect the information on a minute-to-minute and a second-to-second basis.
Out at sea, a large cargo ship traverses the giant waves, carrying parts destined for a far-off wind farm. Tiny sensors throughout the engine ensure everything is working properly. They report back on propeller performance and power output. Other sensors above deck monitor the ship's precious cargo and confirm its condition and safety. The
everything checks out. The cargo is now traveling securely aboard a hybrid evolution-powered freight train. Inside the cabin, the engineer calls up a status report on the entire train. Real-time slows. Between time, a vast universe of data is collected and interpreted. In the blink of an eye, sensors calculate engine temperature, fuel efficiency, speed, weight, and vibration patterns. At the same time, sensors in the track relay the train's location to the network, where information from all other trains comes in. This gives the network the ability to coordinate movement and optimize efficiencies throughout the entire system. And our train remains on schedule. Meanwhile, at a nearby wind farm, a new turbine powers up for the very first time. Within seconds, tens of thousands of data points are analyzed, and the farm controller delivers operating instructions to the turbine, bringing it up to speed with the rest of the farm. Leveraging thousands of hours of stored data, the farm automatically calculates how to increase and decrease individual turbine output. The turbine can tailor the pitch of its blades to capture just...
Okay, so there's two things that you'll see here. The first one is operations and maintenance or asset management very close together. So if we're going to rig up these systems, those two disciplines is, I think, going to grow closer to each other and most probably going to become one department and not operations and maintenance as it is at the moment. But in giving the asset a voice, Darren, I know you start specializing in this area, and there's two significant things. First of all, how do we go about to give an asset a voice? Because we can't buy new assets with voices, so we need to fit them with voices, and we also then need to select the right communication partners and also make sure that we have sensors that can give these assets a voice. Tell us a little bit about the selection and also the whole way that we're going to go about to give assets a voice.
Thank you, Adrian, and good morning, everyone, and thank you for this opportunity. Now, thank you, Dirk, for explaining to us what a digital voice is. And actually, I have a twin brother, and who is a draftsman and produces 3D CAD models. So, am I his digital twin? And am I smart? And well, my wife tells me that I have to stop being such a smart asset. Now, to give this digital voice, to make it successful, I will explain it in 3 main steps. And as you've seen in this example, in this video, that there are quite a few systems and sensors and devices that need to be connected between each other. And you've seen that it's in different areas and different environments, and that's quite a challenge. Now, to explain this in those 3 main steps that you can see on the screen, is first to the left, you have to connect the physical assets or things, and to collect its perception of its surroundings. You have to package this information, transform it to extract meaningful data, and then transfer it to the cloud, where the data can be processed.
And then down to the selection of sensors. If you go out there, I'm sure there's a lot of people that supply sensors, make sensors, but you also need to be economical because there's a cost involved with regard to these sensors. So the selection of these sensors, how do we go about
that's a good question. Yeah, that's a good question. Thank you, Arjan. Now, as I said, to address these issues that we have currently in the industry, you have to start with the collection of this data. And to start, obviously, you have to collect the data and you have to choose which sensors you want to fit to your assets. And now, evolved technology has made sensors cheaper and it's made them more accurate, and they also have a lower power footprint. So when choosing sensors, make sure that they are smart. And what I mean by this is, make sure that your transducer or your actuator, if you want to control your assets, is combined to a processing and communications interface. So make sure that your communications interface is well suited for your application and your environment. And nextly, make sure that, obviously, as I said, with the evolved technology, it's made it more cost effective, so take advantage of that. And make sure that it's low power, especially in cases in industrial applications where your sensors are far from the remote and the control center. And once you've collected this data, you have to then transform it. And in that, I want to look at 6 important features of this transformation. And typically, your IoT gateway is responsible for this function, but your smart sensor can also take this responsibility. And first of all, I want to look at data management. So this includes data streaming, it includes filtering, and then data storage. But Arjun, in this case, you have to be smart about which data you choose to send to the cloud, because it can become very costly when you start sending lots of data to the cloud. Okay? And then next, secondly, I want to look at the protocols. And what I mean by this is the language between your edge device and the clouds. And this can include your MQTT, your NM or your CoAP, and your MXPP protocols. And the selection of these protocols becomes important in terms of your amount of data and also your frequency of data that you send to the cloud. And when you look at device management of your gateways, then you have to look at it must be easily configurable, and in terms of managing your connection between your sensors and your gateways, and then also in terms of its properties and its access control. And then, as you know, security is a very important feature, and you have to address this feature in terms of every layer of your IoT value chain. Okay? And then second last, you have to look at your FOATA, which is your firmware over the air, and this ensures that your security is continuously updated and it maintains your device's integrity. And then last but not least, and again, this is where it becomes quite challenging for lots of the gateways that need to collect data from the sensors. And this is where the language between your sensors and your gateways becomes an issue, and the gateways need to speak to these sensors, which becomes challenging. And it's also where the term interoperability becomes quite important, where you need to share the data between devices and your gateway. And when I talk about the sensor stack, I talk about the language between the sensor and the edge gateway. And this can include your Bluetooth, your Modbus, CAN bus, Profibus, and there's many other types of protocols out there. And we've had quite a challenging experience with trying to connect quite a few of these sensors. But make sure that irrespective of your type of sensor that you use, whether it be legacy, whether it be analog, digital, it must be able to communicate to your gateways. And then finally, once you've collected this data, you have to transfer the data. And as I mentioned earlier, the data transfer costs can become quite costly unless the gateway's got built-in intelligence and it is sensibly configured to choose only the right amount of data that is being sent to the cloud. And your typical connectivity can include Ethernet, 3G, 4G, Wi-Fi, etc. And with remote applications that don't really enjoy, the perks of a well-established IT infrastructure, you can use IT-specific networks such as Sigfox, LoRaWAN, RPMA, and Vodacom Narrowband IoT.
Darren, I'm confused, I'm telling you, all these acronyms, and so all I know is people are really worried about security, so as soon as there's somebody coming along, they ask, will my data be secure? And then obviously the suppliers will say, no problem, it will be secure, and it talks about all these sensor stacks and FOTA and I don't know what else. But the one thing I want to point out is you need an expert to help you to connect your assets and create the infrastructure to make sure that you don't confuse yourself and that you don't confuse the data. And if I go back to the video, one of the things we saw in the video is a lot of ecosystems running in around the same asset. There's operational data, there's maintenance data, there's delivery data, and how do we make sure that we can separate and segregate this data so that we don't mix it up and get the wrong signals on the wrong sensors and so on?
I mean, that's a difficult hurdle to overcome. And now when we talk about sharing of data, Now, the one reason why OEMs and service providers don't want to share the data is because it allows them to control their customer. And anyone seen as a competitive threat has the access restricted. When you walk into a large industrial company, you will see various groups that are separated by cubicle walls. And each group has their own dashboard, has their own applications. And for communication across these different groups, you have to use manual operations such as phone, email, sharing of files. And these data access problems impact almost every industry. So when you look at your IoT ecosystem, make sure that it's open as far as practical, and that your gateway is interoperable and it can share data amongst many devices and systems.
Good, Aaron, thanks for that. I don't know where my voice is, but thanks for that. And yeah, so the next thing we're going to look at is all this data. Now we've connected the assets. We've now got all these gateways. We've got our data secured, and we now have it in some form. And our engineers love data, but there's always an excuse. We can't get time to analyze the data. You know, we've got a few spreadsheets, we look at a little bit of data, and then we go on. And more, the whole thing about data analysis, artificial intelligence, using artificial intelligence, and then also use machine learning to analyze this data. And this is really going to be one of the big things that we need to look at in the future. So Dirk, Stefan, sorry about that. Help us a little bit, and talk about the importance of big data and what big data is all about, and then also this whole thing of artificial intelligence and machine learning. We'll get a little bit later to machine learning, but how does this fit in, and why is it so important to understand this whole thing of big data?
Yeah, morning everybody. Adrian, thanks for the question. Yeah, thanks for the opportunity to address this, because I think it's quite a big challenge, something that we all know is coming and that we need to look into. So maybe to start with, to sketch the picture, I think we've seen many videos, but I think this next very dramatic video also helps to sketch the picture of what the problem is that we face with. So let's have a look at this quickly. As I think we've all said many times now, Dirk, you've referred to it, Darren, about all the data we collect, all these videos that we see these streams of data being generated from assets flowing upwards into the cloud. And if we think about it, our current approach to most of that is that we want to have humans to interpret all that data. We hope to visualize it nicely for them in diagrams and BI models and analytics models. But at the end of it, it's still a human that needs to interpret all that data and then make a final decision. And that's one of the big challenges that we face with, as we connect up more and more of our assets and collect more data, that simply becomes just too much of a challenge. And that's the big issue that we sit with. So if we look at the way we currently try to address that through our human intelligence, what are the challenges that we face with? One of the issues is humans can have lots of experience that we build up over years, but the issue is with the human is you often get the person is distracted by various other inputs. There's emotion involved in making decisions. We don't have the ability to look at huge volumes of data, so what we then often do for ourselves is we simplify that data by either making approximations or discarding some of the information quite early on in the process. And in that we throw away data that could actually be useful in better understanding the problem. That's the one challenge. The other challenge is, our ability to process all this data at the high speed is also not that good. So, if we had to deal with that scalability problem in the old way, we would have just simply had to employ more people and have big rooms full of people looking at this data. But then there's a challenge of all those people speaking together, and interacting with each other to simultaneously look at the data. So those are all challenges that we sit with in our human ability to analyze data and try and make predictions from which we can make better decisions. So what we're seeing, and I think many of you would have seen it, and it's referred to when we talk about the digital twin, and a lot of these videos, I was just looking at the one that showed before Darren spoke. They mention all this data, and it's in a split second all analyzed, and various insights being pulled from that. We know what's going to sit behind that. There needs to be other intelligence that looks at that, and that's where the artificial intelligence really comes in. And I specifically said here, it's augmenting human intelligence. It's not. I think Dirk referred to the digital twin, the ultimate model where you get to autonomy, where your digital twin would automatically detect certain conditions, interpret that, make a prediction, based on the prediction, evaluate the best options, and then actually choose the action and have that action executed. But in many other instances, we will still need humans to play a role. But the benefit we get from the artificial intelligence is, the data can now be processed in almost real time. Once those algorithms are well programmed and set up, they repeatedly make the same good decisions, always taking into account the full context of the asset's operating environment and its performance. So you get much more data processed in a very accurate way. And maybe just one last thing to mention, we've got, we talk a lot about the processing in the cloud. This artificial intelligence is also being pushed to the edge, closer to the assets, so that it can be processed there or
Correct, yeah. So you don't need to send it to the cloud and back. Yeah.
Exactly.
So the first thing is artificial intelligence, using that intelligence as close as possible to the asset to start analyzing. But then there's also machine learning, and I know that again, Warwick spoke about machine learning, and we all fear that machines are now going to take over our jobs. But somehow we need to sift through this data, and it's an ideal opportunity to also start activating another component and start learning machines how to think. But Stefan, how's this learning going to work? How are we going to actually teach a machine to do certain things? And how will they actually start learning and taking these things? Just take us through that, please. Yeah.
Okay, I think I'm going to try and do that at the end of 3 examples, the next slide, without going into all the detail and deep presentation and all that. But there's really, when we talk about machine learning, we must recognize it's actually just one way of creating emulated intelligence, artificial intelligence. And the way it's done, the very simplistic way of that is, one simple model, is where we actually need to train this machine. A machine now not being a physical machine, it's actually a computer program. And what we're trying to do with that is we want to give it a lot of data, and based on that data, we tell it, if you see this pattern, it's good. If you see that, it's bad. If you see this sequence, that's what's going to happen next. Now that type of machine learning we call supervised learning. And a good example of that is we all use our spam filters in our mailbox. Those algorithms help us to identify spam, but we don't set up rules that it says specifically from this email address and specifically if it has these words in it, it's spam. We just tell it this is a spam mail and it needs to look at it itself and based on that decide. So that's the one, the supervised learning. The next one is the unsupervised learning, which is just the next level really, where the machine learning would now actually by itself identify which features describe this data that you're looking at, and based on those features, then start to classify the data. And one good example of that would be, if you these days look at Google and you search for certain images, it brings up lots of other similar images because it identified features in that data to group together the same images. The last one then is, the more complex level of that is what we call deep learning. And that's actually just layers of unsupervised learning. If you think about the whole decision-making process about certain things that us as humans think about, you first consider one set of facts, and then based on that you go to the next set of facts, and you go through a number of steps. And that's what the deep learning emulates. It really takes us the sequence of decisions to get to the answer. So that's very simplistically machine learning.
Okay, so you'll have those intelligent machines and also algorithms that will help us to sift through all this data. So the next thing that comes to mind is, how are we going to use this in an asset management environment? A lot of the videos that we see operations and operational control and so on. But just from a practical point of view, on a day-to-day basis, how will machine learning actually help us in an asset management environment?
I think we've all spoken at length about the application in condition monitoring and interpreting signals and all those type of applications of artificial intelligence and machine learning. But there's many other areas of asset management where it can also play a role. The one example would be if we look at the way we interpret work requests that comes in, and then allocating that work to the right people at the right time. There's a lot of patterns in that can be analyzed and learned from. So then work allocation, and then also the feedback that we get from the work, analyzing that feedback, whether it's in text or voice, that we can learn from that and then automatically decide on the right follow-up actions. That could be one application. The other one is this, it's actually called machine vision, but behind that also just sits artificial intelligence and machine learning of recognizing images, and that we can use in various other applications. The one example up here is facial recognition. So if we think in a safety environment and restriction of access to certain areas, if we had our video feeds actually analyzing people's faces, we would have been alerted to people being in the wrong area. Those type of image recognition can also recognize emotion, and it can recognize fatigue, so it could have applications in safety. It can detect good and bad parts, so there's many of those image processing opportunities as well.
Thanks, Stefan. So there's two practical examples that we can use on a daily basis, and that's in our environments. And I think there's many of these type of areas where we can start use machine learning. Here's a little example of a machine that is programmed to make the appointment, and I'm sure a lot of you have seen this.
How can I help you? Hi, I'm calling to book a women's haircut for a client. I'm looking for something on May 3rd. Sure, give me 1 second. Sure, what time are you looking for about? At 12 p.m. We do not have a 12 p.m. available. The closest we have to that is a 1:15. Do you have anything between 10 a.m. and 12 p.m.? Depending on what service she would like, what service is she looking for? Just a woman's haircut for now? Okay, we have it 10 o'clock. 10 a.m. is fine. Okay, what's her first name? The first name is Lisa. Okay, perfect. So I will see Lisa at 10 o'clock on May 3rd. Okay, great. Thanks, great. Have a great day, bye.
Okay, so the machine will book itself in somewhere in the workshop. It will take it there, and it will get a service, and it will come back. And you don't need to schedule anything or plan anything. So as easy as that. Stefan, thanks for that. Gijs Kappers can't be with us today. Yesterday we were here to talk about Wise Talk and also talk about connection with humans. So one of the big things here is we also need to communicate to humans. If I just look in this room, the amount of people that's busy on their cell phones, either busy WhatsApp or doing mail or processing timesheet, tomorrow you're also going to get all your plant information and all your performance information on your PC or on your laptop or on your device that you carry with you, and you'll be able to make better decisions and more accurate decisions. And again, if we look at the stats, that the connectivity, people want to be connected, so we can't permit people out of this whole picture. And there's people that's build environments where we can very easily, send bite-sized information to people to get them to either recognize something or to learn something or to execute something as we go along, and also to motivate them. If they react to this message, like discovery, yes, there's a cup of coffee for you, yes, there's some free airtime for you. So there's all sorts of things that you can do to make sure that people will read and act on the messages that's coming through. So this whole thing of we want to make sure that people on plants, people responsible for assets, are connected and that they have information on their fingertips to make those crucial decisions. And here's an example of, you can read that quote of Anko Gold Ashanti, where they actually employed some technology to make sure that the alert on safety and safety incidents are taken care of. And that's the result of, of that. So I think in terms of sophistication, we can't omit people in this whole picture. We need to bring people in, and the way we're going to do it, the way suppliers are going to do it, they can interact with your handheld unit, and they can make sure that your information is displayed on your handheld unit. Okay, so let's go to the last step, and this is where things are really getting interesting, and this is the whole thing about augmented reality. Now, augmented reality, if I think about augmented reality, then I really get lost, because they talk about, I must now open that door, and I must wear some glasses to do this and that and all the other. So, Maurits, as we spoke, during this week, I got lost more and more. So help us through, what augmented reality is about. And you also spoke about a number of realities that we can deal with. Let's quickly go through the definition of what is augmented reality in reality.
Thanks, Adrian, and thanks for the opportunity to address this crowd. Just as a starting point, Dirk, when you asked earlier, my heartbeat was 80. It is now 120. But yes, I think it's very relevant to just quickly touch on this topic, because we've got augmented reality, we've got virtual reality, we've got mixed reality, and you can very easily get lost between these, and people tend to also use these terms interchangeably and confuse them. So I'll quickly just differentiate between them. Virtual reality is a computer-generated environment. So think of the VR headsets that you can put your phone into, and it changes your office chair into a roller coaster. Augmented reality is an environment that's been enriched by having digital data superimposed over the real world in real time. So virtual reality replaces the real world, whereas augmented reality enriches it. And then we've also got mixed reality, where computer-generated objects which do not exist are added to the real world. And it's not really applicable to asset management, but if you think about the Pokemon Go game that was such a crazy thing about 2 years ago, in this room we could have different Pokemons walking around, and it could seem as if they're here, but they aren't. And I know Pokemons won't be driving and operating machines soon, but there is actually an application of that in asset management as well. And all of these technologies help humans to make use of information that is stored in a two-dimensional world, two-dimensional format in a three-dimensional world.
And then, Maurits, the whole thing about machine suppliers, OEMs, is now going to supply us with machines that has augmented reality in it, or what I can say, augmented reality infused. Is there an example or a little video that can show us, what this infusion of augmented reality on machines look like, and how would we interact with it?
Yes, I think that's really a point that's become more and more prominent. Is as any technology becomes cheaper, the adoption of it will take up, and also we're starting to see releases of software that can help you with augmented, virtual, and mixed reality applications. But there's actually a few applications of these technologies in industry, and the first one that comes to mind is safety. Safety information about assets and environments, can be overlaid onto them to steer artisans and operators and engineers clear of these potential incidents. And then a second application is where we can actually lock work that requires a permit, and it only becomes available to the artisan or the engineer once the proper documentation is in place. And then finally, workers can be given training in a safe and controlled virtual environment that simulates the real world, which does not have any of these any of the risks of working on site associated with it. And this actually leads me to my next point, which is the way that augmented reality and mixed reality will change the training landscape. An asset's anatomy can be understood without disassembling a single part or component of that asset. And then mixed reality will also allow businesses to provide training without the physical asset being present. And then almost building on this, you can now give training to workers scattered all over the world without having them assembled in one place for a workshop. Just imagine how this is going to reduce the cost of training. And then my next slide is just a quick video on how augmented reality will actually start playing a role in the asset management environment.
That one, I think we've missed that one. Let me go back. There's the, I don't know where that video disappeared. Is that? I don't think so. There we go, sorry.
Just a final comment on this, and I realize that I could have probably put some Mission Impossible music in the background to fit in with the other videos. But I think it's important to realize that these technologies are going to affect asset management in the long run, and we need to start preparing for it because it's going to change the way we design and execute maintenance in an asset management environment. And all these technologies will help humans to almost stay relevant in this ever-growing process.
Okay, and thanks for the explanation of that virtual reality. So the big question is still, are we going to share jobs, or are we going to empower people to make better decisions? Are we going to be able to do better asset management, or are we going to add a layer of complexity that's really just going to make our lives impossible? And my future view on this is, it will definitely create more jobs. It will definitely empower people to make better decisions, and it will put us in a position where we can minimize risk, where we can really run safe operations, where we can really drive uptime with accurate, real-time information. And this is the future that we need to go into. And if I look at all the grey-haired people in this room, we need to start looking for youngsters like this, young engineers out of university that understand these type of topics, that understand these connectivity issues, and that can help us to rig and put these systems and processes together so that we form an ecosystem that can help us with real asset management in a faster, better way, automated processes, automated decision making, and fast decision making. So last question for the audience before we go. Do you think South Africa and our industry is ready to roll this out in mass? Anybody that wants to take a stab on this one? Arnold.
The question is about cost. The question is about cost. How expensive would it be to implement this technology, especially around the training? That's one of the big concerns.
Yeah, so Arnold, all the reading I've done, all the interaction I had with suppliers on this, it's going to cost more money. It's going to cost money, and there's a lot of investment that need to be done. So from a ROI point of view, I think that's one of the outstanding things. If people start doing calculations and doing ROI calculations, and you have to bring in the CAs and CFOs, they go like, this doesn't make sense from an ROI point of view. But if you now look at productivity improvement, if you look at, as you said, training, enabling people that haven't gone through the mold of fixing machines and understanding machines, I think we'll be able to continue with the operations, and that ROI will eventually come out. And everything is also becoming cheaper, cheaper in the way, but it's an expensive exercise and a complex exercise, and we're still learning as we go along. Yes.
Good morning. Okay. Yep. I think that what I see as an interesting thing is where the ownership should be. I still think South Africa is trying to grapple where should the IP be owned, where should the end user, the asset owner play, where should the third party specialist contractor play, where should the original equipment manufacturer play, maintainer, repairer, etc. I still think my sense is there's a battle of how to position that and what's the end one. And how are we going to get to the end one?
So I think it's a good response to that question. So we also need to understand that we won't be able to operate the way that we're operating at the moment. OEMs is going to come into our space with virtual reality. That they're going to help us to make decisions on machines. So their machines are going to come with pre-learned algorithms and so on. So from that point of view, I agree with you. The landscape, and it's not only in South Africa, it's also in Europe, also in America. We always think, we're behind on these things. We're not behind on these things. When we go to overseas, we go to shows and fairs on that side, people are also just going like, ooh, how am I going to rig and put all of this together? Okay, I think, my time is up. I've added another 100 steps to my vitality points. Is there another one? Okay, let's go.
Just a quick comment on the ROI and in relation to augmented reality. How to calculate it? Dr. Keith Swanepoel from Eskom did a calculation called cost avoidance. In terms of, she did a calculation in terms of saying they did the training and they were able to do some type of calculation in terms of cost avoidance. In place of us saying, let us hope that there is an ROI in these training initiatives, we should actually pursue a more analytical approach to calculate these cost avoidance and then measure against the plan. So the plan is the cost avoidance calculation and estimation, and then what is the reality? How much of the cost are we achieving?
So thanks for that input. Okay, so I think we need to stop at this point. And thanks for listening to me, and good luck with your new automation of processes and your digital twin, and selecting the right supplier OEM to help you through this. Thanks a lot.